Hello and welcome everyone to yet another problem from Geeks for Geeks, which says reverse level order traversal. The problem is quite simple and straightforward. We are provided a binary tree of size n and we need to find out the reverse level order traversal. So a level order traversal would be 1, then 3, 2, but here we wanted to go ahead with 3 to first and then 1, so bottom and up. So the last level would be printed first and then goes for the next levels. So same in this case, 40 60, then 20 30, and then 10. Pretty simple, and right from the question itself we are quite clear that we need to traverse level wise the tree. So the first question is quite clear that we need to traverse the level wise for a tree. Now how are we going to do this? So by traversing the level wise, within level wise we can get 1 3 2 all in this fashion, but we need to store 1 by 1 level each, so we will need a data structure within that. So you can have any list data structure over here, and this will contain an inner list of node, and I'll say levels is equal to new, I'll just say array list for now, keeping it simple. So now this list, which is final, we are not going to change this anytime. It's a good practice and you should follow this. It gives you a good impression within an interview. So what it does, it is storing levels is equal to list of level, and in turn a level, as you can see over here, this is a level, this is a level, level itself is list of node. So we can say levels is list of node, levels is list of nodes. So that's what is written over here, and now we need to go ahead and traverse the tree. And you know pretty well that how do we traverse a tree in a level order fashion. We take a queue, and within a queue we put a node, and it's a node queue. Let's take it as linked list just for simplicity, nothing much. Don't worry about the underlying data structure, it's just a queue. And now this queue would be having the initial node within. So while I see node is not equal to null, we are going ahead and iterating it. But how do we know that we have reached the end of the level? So we'll add a marker over here. The marker would be nothing but null, and that's great. So we take out the current node. Current is equal to q dot poll, and if current is equal to null, we know that we have end the level. So the level is end. So why so? Because post 1 we are seeing null, that means this level is ended. Post 2 we see null, that means 3 2 the level is ended. So in that case we are going to have levels dot add level. But wait a minute, what is the level? So level is nothing but a simple data structure which stores level value. So level would be, as mentioned earlier, level is nothing but list of node. I'll just take it over here. So list of node is a level. Let's continue. I'll take array list, nothing much fancy over here. Yep. And now end the levels, reset the level. So level is equal to new array list. But and ultimately we don't want to proceed, so continue from here. Also we see a node. If current is not equal to null, then current has a node, so let's add that node within the level. Now it's our job to go ahead and populate left and rights. So if current.left is not equal to null, I'm populating within queue current.left. It is proper level wise traversal fashion. Current.right is not equal to null. In that case as well, queue.offer current.right. So this is nothing but a standard BFS traversal. Cool. So far so good, but we need to tackle what if my current is null and the next of null is also null. So here we need to add a marker over here as well. So current is null and hence we are adding queue.offer null. So here we are saying we don't want to miss the marker, because let's be honest, if we do not offer null, then we will never ever come to know that hey, the level is ended. So when do we know that this level is ended and this is started? And when do we come to know when this level is ended, or this level, everything below it is within the queue, and hence when we see null, we add null here as well. So in order to mark that beyond 3-2 it is a level end. Same goes with the 20-30. So when 20 and 30 both are traversed, we see 40 and 60, and beyond 30 we see that there is null, and hence within 40-60 we append null. That's what we are doing over here. But can we see over here that there is 2 times we are populating null? So there must be a check. If q dot is empty or q dot peak would be null, then in that case anyways the nodes or levels are finished, so we can break the loop over here. So we'll do it over here, do this over here. Why we are doing it over here? Because we don't want to lose on levels. So we want levels to have a level, the earlier level which I have stored. Check early exit, I'll say. Cool. And within the end it demands array list of integers, which is of course in the reverse order. So what we'll do is list, or rather array list, to make type safe integer, and we are saying result is equal to new array list for sure, and for we'll traverse levels in the reverse order, and we'll go ahead and directly dump them. So int I is equal to levels dot size -1, I is greater than equal to 0, and I plus plus. Now for int node what should I say is a node within level dot get I, and I'm directly adding result dot add node dot data, return result. So will the solution work? Let's check it out with the sample test cases. So it says node is already defined. There's a compiler error within our code. So let's get rid of it. And not a proper naming, but let's go for now. This okay, makes sense. We need to keep it minus. That's the case. My bad. So yeah, it works with sample test cases. Let's check for rest of the test cases as well. Yeah, seems it's pretty neat. It took more time than expected. Why so? Because creating and resetting the objects within Java takes much more time than usual, because we go ahead and we access heap memory, which is not always recommended. Do we have any alternative? Yes, of course we have any alternative for that. We can, for instance, instead of storing the entire level by level, we can only store a level, and at the time of saving, which we are saving over here, we can reverse it and we can store directly within the result. That can be done, but the solution becomes a bit complex to understand, and it requires a very good understanding of code, and that can be done against the readability. So readability can be reduced and the code could be optimized, but this is by far the best solution, and you won't even achieve a very significant time lapse. Overall, the time complexity is still O of n and space is O of n. So not going to compromise on that, and that's it. The only case is the runtime can be a bit faster within a bigger systems and microservices. It's not even considered. So that was all about it. Do let me know, and for more such awesome content, I'll see you in the next one.